Now we can quickly summarize how to fit rest of the models. So for now we have seen about naive model, random intercept model, and also random intercept at two levels for doctor level and also institution level. Now we can see how to fit a random intercept and a slope model only for the doctor level. As you can see, the only change is instead of 1, I have given age here. So it's basically fits the random intercept and slope model. As here you can see, this is random intercept and slope for doctor level, and the results are viewed. The next one is random intercept for institution and random intercept and slope for doctor. So in this case, what I'm trying to do is only intercept should change for the institution level, but for doctor level, the slope is also should change. For institution level, the slope should not change. That is the condition over here. For that, what I have did, institution is equal to tilt of 1, comma, MD is nothing but doctor level is equal to PD SYMM, which is nothing but symmetric variance covariance, which is used to fit the random intercept and slope for only one variable. This is a special function what we use at this stage, and we can fit this model. So this is the model. Random intercept is only changing for institution level, and the random slope and random intercept is changing for doctor level. And next model is random intercept and slope for both the levels. Now I want to change the slope for both medical doctor level and also institution level. For that, I can just, it's similar to how I did for 2 intercept. Instead of 1, I'm just replacing with h over here, so that the slope is changing for both the levels. As you can see, the slope is changing for doctor level with respect to age, and also the slope is changing for institution level with respect to age. So that's how we will fit different kind of models. Is there any doubt in this? So multivariate. And this one is multivariate. So Sar explained about how to center age center, why we use age center instead of just using age, because in some cases the estimation it will converge, so we have to do age center. So we can see how to do that. First, I'm calculating the center age here. I'm centering the age, just a variable age. So I'm just defining mean age is equal to mean of cholesterol of age, and comma na dot rm is equal to true, which basically says remove the missing values. That's all. And this will calculate the mean. The mean age for the data is 61.8. Now what I'm doing is I'm calculating the centered age now, which is nothing but age minus mean age. So we have created the age center. As you can see, age center is calculated. Now we can fit the model. Here you can see I have used age center. And what kind of model is this? Can anyone say? By seeing? Yeah, correct. It is a random intercept and slope model, and the slope is varying with respect to the age and only to the doctor level. And you can see the results, which is a random intercept and slope model, and the estimates are given over here. Similarly, I'm doing centering BMI now. I'm going to add additional variable. Now it is multivariate now. I'm going to center the BMI also with the same technique, mean BMI, which is 31.2 for this data. The mean average BMI is 31.2. Now similar way, I'm calculating the BMI centered. And you can see that the data set BMI centered is also there. So I have calculated BMI centered also. Now I'm adding the BMI centered as another covariate. And you can see the result which is explained by Sir in the session. And also I'm calculating the age of the medical doctors. I'm centering that age of the medical doctors also. And just adding, instead of BMI centered, I'm adding age of the medical doctor centered. And you can see the results here. What? No. Yeah, that's how we will. This is multivariate, just adding another variables. That's all. So is there any doubts how to fit any kind of models giving intercept or slope?